Hello, everyone. My name's Kate. Thank you for coming. Today, I'm going to be talking about audit logging in Kubernetes. Specifically, the goal of this talk is to talk about what audit logging actually is, go over a couple of the challenges with it, and then talk about how we can address those challenges. Before I get into it, quickly introduce myself. My name is Kate Kuchin. I am a software engineer at Heptio, although as you may have heard, literally a few minutes ago, Heptio has ceased to exist. So as of 1 p.m., I'm officially a senior member of the technical staff at VMware. I'm super excited to keep working on a lot of the problems we've been trying to solve at Heptio at VMware. And George up there, he's excited about everything, so he's amped too. At Heptio and now at VMware, I work with a great group of humans, a lot of them who are here right now, and we're focused on building products that make Kubernetes easier to adopt, easier to use, easier to debug, easier to just generally derive value from for both cluster operators and app developers. My team consists of some lovely back-end focused engineers, those of us focused on the front end, a manager, Eric, he's great, and of course my dog Helen, she's the MVP of the team. So what has this group of humans been working on? The lot of us have been working on a project that's designed to empower cluster operators to more easily manage their multi-cluster, multi-cloud fleets. The motivation here is that as we start seeing more and more workloads migrated onto Kubernetes and the public cloud, fleets of clusters are becoming more fragmented. So some people in your company might be running on-prem, some might be using AWS, some might be using GKE or Azure because they want to use Cosmos and Databricks. And cluster operators need a way to manage all of these at once. Audit logging is this super powerful tool that grants operators more insight into their clusters. They can tell us what happened in our clusters, who did it, when it happened, and what resources were affected. The problem is that it's kind of hard to set up, and even one fairly stagnant cluster generates literally millions of audit logs each week. So if you're running multiple clusters across multiple clouds, it's certainly not unheard of for companies to have hundreds or even thousands of clusters. Suddenly, and each of these is spitting out 1 million audit logs a day, it's going to be pretty difficult to isolate logs that actually matter. So that's what we're trying to help operators and app developers do. So those are some of the things my team at Heptio has been working to solve, and we'll continue to be working on the VMware. I'll do a little demo of what we've been working on at the end of this talk. I don't think you want to watch me use a website for very long, so it's going to be quick. But if you're interested in seeing more, head over to the Heptio booth. We've got these very fancy iPads. I'm happy to go more in depth. All right, I'm a firm believer that you should never attend or schedule a meeting without an agenda. The same goes for this talk. So briefly, here's what I'll be talking about. First, we'll be going over what Kubernetes audit logging actually is. We'll talk about what 6 questions it answers, we'll talk about audit stages, and we'll talk about audit levels. Then we'll talk about configuring audit and some of the pain points there, as well as a new feature in 1.13 alpha, dynamic audit configuration, which alleviates some of these pain points we'll talk about. It's something my buddy and teammate Pat has been working on upstream for a few months, and it's pretty cool. I'll do a quick little demo just to show how easy it is to get dynamic audit set up, and from here we'll talk about making sense of the audit data. Like I mentioned earlier, every cluster generates a lot of data, and extracting meaning from millions of logs can be pretty tricky. Finally, we'll move on to a technical preview of this thing that we've been working on, chat a little bit about the kinds of problems we have to solve with it, and then, if I've left enough time, I will answer questions if there are any, and if you're nice to me. All right, next up, let's get started. So what is Kubernetes audit logging? I'm just going to say audit logging from now on because that's a mouthful, and why should you care? Simply put, audit logs record all the requests made to the Kubernetes API server by admins, users, and components of the system itself. That means anytime you apply some YAML, do a kubectl get, a kubectl watch, you're going to get some audit logs. But it also means that every time the system does everything, which is, spoiler, literally all the time, you're also going to get audit logs. What we're left with is a chronological set of records that document pretty much every activity that's affected the system. So why should you care? What good is this? Audit logs can be used for a number of things. I like to bucket them generally into 3 categories: compliance, anomaly detection, and event attribution. A kind of classic use of audit logging, not just for Kubernetes, but for all systems, is compliance. So if you are a financial institution, you need to be compliant with certain regulations, and you can send your audit logs off to some external auditor who will make sure you're not doing anything sketchy. I'm not going to talk too much about this. Also, because audit logs record every request to the Kubernetes API server, we get a trail of who acts on what when. By watching the state, a kind of like normality can be understood, right? So we have a baseline and we can potentially detect when anomalies exist. So if you're used to seeing a certain number of a certain kind of events and that number ticks up, that could be an issue. Or perhaps we want to geomap all of the requests to the API server. If you're used to seeing things from Oakland and from Seattle and from Kansas City, and suddenly someone is accessing the cluster from Italy and like no one's on vacation, you probably know something is going on there. Maybe you're seeing a lot of 403 requests, a lot of 403 responses to anonymous requests. Like that could be an indication that there's bots crawling around looking for vulnerabilities. This is a little trickier than it sounds. Like we're talking about one or a few suspicious logs amongst tens of thousands generated per hour, so most anomalies are not going to be immediately apparent. And finally, the most basic concept of audit logging is simply saying who did what when. This is sort of the core value that audit logs provide. But we can expand on it a little further than what you get from just a trail of audit logs. We can display audit logs in a more digestible way. We can filter out the system events. We could even start doing things like event tracing, where you can follow a chain of causation in audit logs to get to the root cause of something. So if an application goes offline, we can investigate audit logs and see that the pod running the app container was deleted by the system. But if we dig a little deeper, we can see that someone either maliciously or accidentally deleted the deployment that was deleting the pod, that was controlling the pod. So because we have a record of every single event that happened up until the pod was deleted, we can trace the action through the server and understand exactly what happened, who did it, when it happened, and with that data, we can hopefully understand a little bit more about why it happened. Okay, that was sort of a high-level overview. I'm gonna go a little bit deeper into what audit logs actually look like, so we get a little deeper understanding about how we do all of those things with them. Each audit log should answer 6 questions. What happened? When did it happen? Who did it? From where was it initiated? What did it happen on? And where was it observed? This is generally what we can expect an audit log to look like. I don't expect you to read it. But depending on the level and the stage the request is at, this blob is going to be bigger or smaller, but all 6 of these questions are going to be answered in every log. And we'll talk about stages and levels after we go through an audit event. So let's break down this event. So how do we know what happened? We have a verb, get. If you're used to interacting with Kubernetes via kubectl, these are things you know. Get, watch, patch, create. That's usually what the verb is going to be. When did it happen? We got a lot of information about when it happened. We get a bunch of timestamps about the current stage it's in, when it was created, when the request was received, and we also know the stage of the audit log. Who did it? Again, a lot of insight here. We get a user and a username and what groups they're a member of. So we can see here that this is a system user, it's a node, and it's a member of a couple of groups. Again, we can find out a little bit more about who did it by knowing where it was initiated, and this is just an array of source IPs. And what did it happen on? So right now we know we're looking at a system node event. It's a get. It happened like 3 weeks ago whenever I made that slide. And we now know that it was on a pod. So it's a get of a pod in the default namespace with the name populator 5, whatever, and whatever. And finally, where was it observed? This is the same for every single audit log. It's literally always the API server. Every single audit log occurs on the API server. If you don't interact with the API server, you're not going to get an audit log. So if you are a malicious user, SSH into a node and create some binary that's mining Bitcoin or whatever other threat model we're using these days, it's not going to get recorded in an audit log because no one has interacted with the API server. Okay, so that's briefly what an audit log is. Let's look at the different stages of when these logs are generated. We have request received, which is when the audit handler receives the request. Response started. We only get those for things like watch, longer running requests. Response complete, that's when the server is done and no more bytes are going to be sent. We've dealt with it. And then panic occurs when a panic is generated on the server. Let's just walk through this quickly to go through the life cycle. So this is roughly what we can expect it to look like. It all kicks off with a request to the API server. Again, a get, a watch, a create, something like that. At that point, we get an audit log with the stage request received. From here, we can see what the server response is going to be. It could either be a no-go, and the server could panic, and we'd get a panic log, or if it's a longer running request like watch, we'll get a response started, and when it's done, response complete. For a lot of logs like gets, you would likely see just 2 of these, the request received and the response complete. But the key takeaway here is that for every event, you're not going to get just one log, you're likely going to get a couple of these. Oops, missed one. All right, so I mentioned audit levels briefly. I just want to go into what those are because audit levels basically is how we configure how much data we want each audit log to consist of. So we can do none, which means we don't want to log anything about certain resources if you're just not interested. You can do metadata. This is really interesting for things like secrets because you probably don't want to be sending like the full body of secrets across the wire because they are a secret. Request, this is the full request body, and then the most robust is request response. So this is, you get both the full request body and the response object in your logging. So if I were to set a policy, it might look something like this. You can see this is just a Kubernetes object with a kind policy. I'm going to emit the stage request received. I'm only interested in metadata, and I'm only interested in secrets. So what that would come out to is a log that looks something like this. And even though this is a fairly restrictive policy, we can see that it answers all 6 of those questions we talked about earlier. What happened? We look at the verb, it's a get. When did it happen? You got a bunch of timestamps, you can see all those. Who did it? It looks like someone named Dolores, robot or a human, I don't know. And then it looks like it's coming from a source IP of 10.0143, and this happened on a secret in the default namespace. If you're interested in kind of going into a deeper dive of what I just flew through, there is a talk tomorrow on auditing. It's up on the 6th floor. It's at 11:40 in the morning. I don't have time to fully go into it, but that's just a high-level overview. And that talk is by Mache and Stefan. All right, so now that we hopefully kind of know what auditing is, let's go over, we know what auditing is, and it gives us insight into who did what when, which is super useful for things like compliance, anomaly detection, and event attribution. So we like it, we want it, let's do it. All right, for the bad news. First, you've got to try to configure audit before. First, if you've tried to configure audit before, you know it's a pain, right? And second, once you have it configured, you're left with this massive amount of logs that you need to somehow make sense of. So how do we solve these problems? Let's start with configuration. Currently, if you want to configure audit on your cluster, you have to have a really good understanding of how your Kubernetes installer works. You have to know where your Kubernetes installer looks for manifests and then SSH into that spot and copy up some files. Which brings us to the second issue. Even if you have a handle on how your installer handles these types of updates, like you know the kubelet looks for manifests and etc/Kubernetes/manifests on the master node, you still have to do some pretty precise and often frustrating configuration. You have to set some flags, and then you have to copy up multiple files to the master node, like your audit policy file we just talked about. And finally, once you've got all of that sorted out, you have to restart the API server to apply the changes. What's super annoying about this is even if you've made any mistakes, which if you're like me, you definitely did, you're going to have to go back and do it again and restart the API server again. If you've done this before, I would guess you got frustrated. Otherwise, you're much better than I am at this stuff. Okay, so what's the problem with this beyond it's annoying, which is a big problem? So cluster operators, you know, they have to copy up files to the master node, then restart the API server on every single iteration of an audit policy file. So if they want to ever update their audit policy, they have to SSH into the master node, figure out what file they need to update, hope they don't make any indentation errors, restart the API server, and then do it again if it's not configured exactly right. It's not a trivial task, and it's definitely harder than it needs to be. For app devs, it's even more frustrating because we're often stuck with the configuration that's been set by cluster operators. So if I'm trying to debug an application and I want more than metadata to figure out what's going on in the request body, I can't turn up the audit logging level without doing the whole SSH, restart the API server song and dance. It's not exactly an ideal workflow. For third-party app devs, like me, who want to build applications for people to use audit, we can't drop audit facilities into other clusters unless we know that they have audit configured in exactly the way we need it configured on the master node. So if it's not like that, you're pretty much out of luck and you can't have like these really cool third-party apps. Which brings us to dynamic audit configuration. This is brand new in 1.13 and it's still in alpha, but it is super cool and it alleviates a lot of the problems we just talked about. So what is it? Dynamic audit config is a set of objects, some API server flags, and audit sync objects that allow you to configure auditing features dynamically. It's a good name, I'm sorry I couldn't come up with a better definition. So to enable audit on your 1.13 cluster, all you need to do is set these 3 flags on your API server. One of them is just turning on alpha, one is enabling the feature gate, and one is actually saying, yeah, I want audit dynamic configuration. When this goes to GA, you're only going to need the one flag, and this might even be a default flag, so you won't have to worry about that. The other thing you need is an audit sync. An audit sync is just a Kubernetes object, like a deployment, like a pod, like anything. It's just some YAML, and you can do it with the and you can apply it with the kubectl apply or create. So the audit sync sets the logging policy and defines the endpoint for where you want to send the logs. A couple of things to note here. You have to use a webhook for dynamic auditing. You can't just write it to a log file. So you will need a URL or a service to send it to. The other thing to note is that stages are defined slightly differently. I don't know if you remember, but in the other policy I showed you, it said omit stages. For this new policy definition, we just say stages. So it's a white list of stages you want to receive. So how does this help everyone out? Cluster operators, once it's set up, they can just create audit syncs to their heart's content to set new audit policies. They can update them, they can create new ones, they can enable new third-party applications super easily. App devs can easily also just create an audit sync once it's turned on, and they can turn up audit logs so that they can debug their applications more easily. And third-party app devs can write an application that includes an audit sync in its definition, so they don't need to worry about if the cluster is configured properly that they're dropping their application into. Okay, super quickly, I'm going to do a demo of it in a second, but just to make sure everyone's aware of a few things, this is still an alpha, so maybe don't go flipping it on in prod quite yet. There will be an increase in CPU and memory. This is because every audit sync creates a buffer of 5,000 events. It's fine if you got a few, it's pretty nominal, but if you're doing like 100 syncs, it's not going to be nominal, so don't do that. They are working on that though. Right now, so creating an audit sync means you can pipe logs at any level to anywhere. So it should be a cluster admin level coverage. Like you don't want people piping secrets to themselves or whatever if you don't trust them. It doesn't support auth, but they are working on that. So you will need to get a cert from the API server, and that's sort of difficult. So I'm not doing it in this demo. It's a very insecure demo. Don't do what I am doing. And policy is scoped down for now, and so you'll need to handle a lot of like the resource filtering by a proxy. The reason for that is that they're introducing a new thing called audit classes, which is going to make audit syncs composable. It's very cool. I'm happy to talk to you about it after the talk. All right, so let's do this really quickly so we can see how easy it is. I used Kind for this, Kubernetes and Docker. It's really easy. If you haven't tried it out, I recommend it. Very outside of the scope of this talk, but it's cool. So it's just a super easy way to get a cluster up on your local machine, and all you need is Docker. So what I need to do is I just need to create a Kind cluster. So this command right here, I am building a node image. This isn't always necessary, but Kind is currently at 112, and I need a 113 cluster, so I had to build it from source. After that, I'm just going to run Kind create cluster and set this image tag, this image flag, to use the image I just built. And then we also have this other flag that's config, and this is the kind config.yaml. This is where you're going to set your API flag, so you have audit enabled. This is roughly what the kind config.yaml would look like. You can see here there's some indented YAML. That's what that pipe thing is. It's really ugly, but that's what it looks like. And underneath the pipe, that's the YAML in the YAML. That is exactly how you would set this up on kubeadm, because Kind is running kubeadm under the hood. So you can see there's an API server object with some extra args, and those three things below extra args. Those are the three flags we were talking about earlier. All right, so let's do it. I'm not going to build it for you because I'm going to spare you, but let's go ahead and run it. Is it going? No. Uh-oh. Okay, I might not be able to do a demo. I don't know how to make this play. All right, well, I'll just talk through what was going to happen. So once I've got my sorry. Okay, so basically I'm going to run that command. I'm going to create a kind create cluster image, and then I'm going to set a config. And we'll see it spin up and watch. You can kind of see what's happening in the screenshot. And then it'll spit out a kubeconfig that I can copy paste, and then I can interact with the cluster using kubectl. It is going now. Okay, sorry. So now it's doing all that stuff. Great. So we've got that. So once I have my kubeconfig copy pasted, I can interact with this cluster now directly through kubectl. So I'm going to quickly build a pod. This is the sketchy pod I was telling you about earlier that I'm going to send my logs to. This is not something you would actually do. You would normally send your logs to something like a Kibana dashboard. But for the purposes of this demo, I'm just spinning up another pod in my cluster to send the logs to that's going to spit out all the logs that Audit is producing. So we'll do that. Okay, so that's me getting my kubeconfig. All right. So now what I'm going to do is I'm just getting the IP that I need to send the logs to. Then I'm going to check in my audit sync once I have that IP and make sure that that IP that's at my URL matches the IP that the pod is expecting. Pretty simple. And then from here, I'm just going to tail the logs of that endpoint pod. I believe that's what's happening. Oh, no, that was me creating the audit sync. Now I'm going to tail the logs. Voila, we have a bunch of audit logs. So this is like what raw audit data would look like in your cluster. There's a lot of them. And we can see pretty immediately that this is like just a lot. This is like a small cluster on my local machine that has been up for 30 seconds at this point, and we already have a ton of logs to go through. So you can kind of imagine like how out of hand this would get on a cluster that you're using in production every day. Okay. So there's some great work going on upstream to help alleviate the pain of configuring audit, but how can we make sense of the audit data once we have it set up? I've mentioned this a few times, but I just really want to emphasize like how much data we're talking about. It's a lot. It's like a preposterous amount of data. As an anecdote, when we first started building out this feature, I'm going to show off in a minute, Ross, our designer, designed this view with something like 142 logs per hour, and we were like, oh yeah, cool, that looks good, great graph. Seems reasonable. But once we hooked it up to a real cluster and realized just how aggressively wrong we all were. We were seeing something like 1 million events every day, and we had to pretty seriously rethink how we wanted to display that data. So just to give that some color, I want to give an example of one interaction with the API server. So if I'm a developer and I just want to create a simple deployment, assuming this command successfully creates, you can expect to get at least 3 logs that are attributed to me. A get, that's checking to make sure the deployment I'm trying to create doesn't already exist. That's going to fail. A create, the actual creation of the deployment, and then a list, just making sure the deployment is there and everything's copacetic. So 3 events for that one action. Meanwhile, the system generates around 40 events for that one action. Kubernetes needs to spin up a replica set, the pods, do gets, updates. I don't know, there's like a bunch of gets that happen at the end. It's a lot. And I couldn't even fit all 40 on one slide, but these do actually represent like a real Nginx deployment that I spun up. To give that a little more color, I've got a pretty stagnant cluster I keep up that has audit enabled on it. I really don't interact with this cluster at all. So the logs it generates are just logs generated by the system to keep the cluster healthy. So this is a cluster that pretty much exists in my heart and on my AWS bill, and that's it. And it is still spitting out 60,000 audit events per hour. So that deployment that generates 40 events, it seemed like a lot in comparison to the 3, but when you're wading through 60,000 events in an hour, isolating those 40 events, much less the 3 events, becomes pretty difficult unless you know exactly what you're looking for. Which brings us to what we've been working on at Heptio. So our team has been working on a product that's aiming to make audit logs something more than just a lot of data about your cluster. We think there's a ton of value that can be derived from audit if you just know where to look. So our goal is to start surfacing information to cluster operators that is readily available in audit logs, but isn't easily findable unless you know what you're looking for. In a lot of ways here, audit is just a piece of the puzzle. If we don't know something is wrong or we don't know what we're looking for, audit logs aren't going to alert you to the fact that something's amiss in your cluster. This isn't like an extra layer of security. But once you do know something is wrong, we can use audit to figure out why it's wrong. Okay, I'm going to have to hope this works. All right. So this is the project that we have been working on. You can see here I've got a fleet of clusters. I'm going to move so I can actually see. We've got some GKE clusters, we've got some PKS clusters, and we have this AWS cluster that has a warning that there's disk pressure. So I'd click into that, and then I would see this cluster overview page where I could see, yep, I've got 2 nodes, and one of them appears to have some kind of warning. At that point, I could investigate a little bit further, go look at some nodes, and yep, that doesn't look great. Disk pressure, a little bit higher than I'd expect for the allocated CPU. So at this point, once I know there's something up, I could go into audit and try to figure out why it's up. Really taking my time on this one. All right. Okay, so this is the audit page. And right off the bat, we can see that there are 37,000 events in the last hour, and that looks like even with some sort of dip in the API server, there might have been an outage, which is why it's a little lower than 60. But it's still pretty consistent. Like, there's not really a lot you can tell. There's like a little bit of a spike here and there, but nothing that would necessarily bring off any alarm bells. So at that point, I would just toggle off system events and get only user-created events. This is a little more useful, right? Like, suddenly we're seeing a couple of spikes, and like that could very well be the problem that's going on. The spikes before are me messing up the demo the first time, but this last spike is the one that we'll go in and look at. So if we scroll down, we can see this overview of all of the audit logs. So this is the same exact data I just showed. There was like blobs of JSON on a terminal, but it's just displayed a little more nicely. So we can see we've got some very bad, scary app stuff going on. That doesn't sound good. So I'm going to click into that and see if I can answer those 6 questions we talked about earlier. You know, I can see here that it's a create. I can see who created it, Fabio, typical Fabio. And I can see what namespace it's in, so I can know where to go look for it. I can see the source IP it was created for. I can figure out all of these things I need to know as a cluster operator to go and actually fix it. So at that point, you know, I could go into my terminal and just really quickly do a get of my pods in the namespace. I have a lot of typos in this. I didn't feel like redoing it. There they are, very bad, scary app, 52 seconds old. And I'm just going to delete that pod because I'm pretty sure it's suspicious. And so once I've deleted it, I could go back to HQ, go back to the project and see that the cluster is healthy. Again, there's a little green dot next to the cluster name. And I can go in and I can filter by very bad, scary app and see not just the events that Fabio created and the system created, but also the events that I created when I went and deleted the pod. So you have like a full picture of what happened, like when it started, who resolved it, and you've got all of that traced, and you've got it traced in a way that you can actually understand. Okay, I'm about done. So when I was preparing for this talk, I had people ask me what I'd be talking about. When I reply with audit logging, I'd pretty universally be met with either like very blank stares or something along the lines of, oh, that sounds like really boring. I think both of these reactions kind of capture the 2 problems we have with audit, right? The blank stare comes from, what on earth is audit logging? Do I even have that? Do I want that? How do I configure that? And the abject boredom comes from people who have audit logging and are just like, oh, cool, like that mountain of JSON I like literally never look at. So hopefully you all come away from this talk feeling like you can get audit set up and understanding why you might actually want to look at that pile of JSON. And one of our goals for the next few months, both upstream and in the things we're going to be building at VMware, is to keep addressing these problems. When dynamic audit gets to GA, for instance, and maybe it will even be enabled by default, it really will just be as simple as creating audit syncs to get audit policies set up. And once they're flowing, we hope to keep building out solutions like what I just showed you to make them useful and hopefully a little bit less boring. So with that, thank you all for coming. I will be over the Heptio booth for a few hours, or if you prefer, you can find me on Twitter, where my DMs are not and never will be open, but you can at me. Thanks again. I think we have a few minutes for questions if there are any. I don't think I quite hit it. Yeah?
So with the volume of logs, couple that with running clusters with many different cluster sizes of pods and fleets, hundreds of thousands.
Yeah.
What have you seen or what has the team seen that there's potentially a pitfall from running large scale fleets? Anything that we should look out for gotchas of like in the Kubernetes ecosystem?
So the question was, in large-scale fleets running hundreds, thousands of clusters, what are potential pitfalls we've seen? Is that correct? You know, I'm not sure that I'm qualified to answer that question, to be perfectly honest. There are many, I'm sure, but if you want to come to the Heptio booth, the field engineers like definitely have experience with that. I'm not one of them. Thanks for the question, though. Yeah.
If you're taking a managed Kubernetes cluster on EKS, for example,
Mm-hmm.
our ability to influence API server is much
None, yeah. So if the API server flags that we were talking about end up being enabled by default, then maybe we will be able to use things like the project I showed, but it'll be up to the cloud providers if they're going to flip them on or not. Yeah? Yeah. No, dynamic audit config itself won't eliminate the system events. You will still have to have some sort of proxy to filter those out. They'll still be there. Yeah. Yeah.
Is there a way we can configure the type of audit logs we receive, like we just need request received or response completed, so are you planning any such?
Is there a way you configure the kind of logs you receive to limit the number of logs? Yeah, so you use something like an audit policy that I showed at the beginning of the talk. So you could filter it down by resources. You could filter it down by the stage of the log. You couldn't do something like filter out anything by a system user, though. That's currently not in the scope of policy. But you could do it by resources and by stage. Yeah. All right. Thank you, everyone.